Hi, in this session, we are going to give a brief overview on clustering different types of data. We encounter various kinds of types of data. For example, the early clustering algorithm, most times the design was on numerical data. And the second type of data is category data, including the binary data most people consider as also can be handled in categorical data category. For example, gender, race, zip code, or market basket data, you will consider the data is discrete. There's no natural order. For third kind of data is text data. This is very popular in web, in social media, on the web, or social networks. Usually, if we consider a word as one dimension, then we are handling very high dimensional data, but they are very sparse. Their value usually corresponding to word frequencies. The methods to handle such data include a combination of k-means and agglomerative methods, topic modeling methods, or co-clustering methods. We are going to discuss this extensively later. Multimedia data is another kind of data needs clustering. Usually images, audio, video, those on Flickr and YouTube actually are multimedia data. They are multimodal in the sense they have image, audio, video. In many cases, they have text as captions as well. We can consider they are contextual data. They contain both behavioral and contextual attributes. For example, for images, we can consider the position of a pixel represents context, the value represents behavior. For video and music data, we can consider temporal ordering of the records represents its meaning. Time series data is another popular encounter data like in sensors, stock markets, temporal tracking, or forecasting. Those tasks usually we handle time series. Time series, we usually consider data are temporally dependent. They are consecutive. Usually the interval is somehow equal. Like we can consider time as contextual attributes, data value as behavioral attribute. Usually such analysis include correlation-based online analysis like online clustering of stocks to find stock tickers. Or we use shape-based offline analysis. For example, we can cluster ECG based on overall shapes. Sequence data is another kind of data, usually in weblog analysis or biological sequence analysis, or analyze the sequence, the system commands. We can think the placement rather than time are the contextual attribute. That means where they are. Okay. Then the similarity function include Hamming distance, added distance, longest common subsequences. The clustering method we call sequence clustering may use suffix tree, may use generative model like a hidden Markov model. Stream data is another kind of data. Stream data can be considered as a real-time data like water flowing in and out. It may evolve along time. It may have concept shifts because stream coming and go. So we need a single pass algorithm rather than you can see it again and again. And the typical method for stream clustering could be microclustering. That means we need to create efficient intermediate representation by some kind of microclustering methods. Graphs and homogeneous networks is another kind of data. This kind of data usually so-called homogeneous networks. That means we consider networks as graphs, but nodes and edges actually are of one kind, one type. Actually, any kind of data can be considered, can be modeled as a graph with the nodes as different attributes and entries, and edge represent their similarity values. Okay. The typical method for handling graph clustering could be generative models, combinatorial algorithms like graph-cuts, spectral clustering method, non-negative matrix factorization methods. Then a little beyond homogeneous networks are heterogeneous networks. This kind of network consists of multiple types of nodes and edges, like a bibliographic data, hospital, handling disease, patients, doctors, and treatments. To cluster different kinds of nodes and links together, there are some interesting algorithms like a netclass algorithm. Uncertain data means the data may contain noise, may have approximate values or multiple possible values. Usually we need to incorporate some probabilistic information like distribution or approximate values that will improve the quality of clustering. Okay. Finally, recently there are lots of discussion on big data. That means we can model systems that may store and process very big data like weblog analysis. Usually, like Google's MapReduce framework is you have map function to distribute the computation across many machines. Then we have reduce function to aggregate the results obtained from the map step. So we can see the data is very rich. That's why the clustering is a rather sophisticated methodologies, trying to handle different kinds of data. Hi, in this session, I'm going to give you a brief overview of user insights and clustering. Usually, users may have some interesting insights or views. User may like to interact with the clustering process to influence the final results of clustering. One interesting one is visual insights. Because a picture is worth 1,000 words, human eyes are actually powerful, high-speed processors because they are also linked with rich knowledge base. So a human can provide a lot of intuitive insights on whether this clustering result is good or something they desired is not achieved based on the current clustering result. Okay. There's usually user is good on 1 or 2-dimensional, at most 3D. They may be able to find clusters. There are algorithms. For example, HiDi is how to visualize high-dimensional clusters. The second one is semi-supervised insights. That means user may have certain insights or intention on the clustering process. They may like to pass their insights to the system to influence the results of the clustering. For example, user may provide some seeding. That means you can provide a number of labeled examples or some approximate representation of the categories of interest. Then you may like the clustering process to take your insight to do some desired clustering. The third one is multi-view and ensemble-based insights. So-called multi-view clustering is different clustering may generate different perspectives. The multiple clustering, you can ensemble them together to provide more robust solution. Finally, a very important one is validation-based insight. That means you may want to evaluate the quality of the clusters generated based on certain validation methods. For example, you may use case studies, or you may provide specific measures, or you may provide some pre-existing labels. All these we're going to discuss in detail in some chapter. Finally, I provide a few reference books, and especially the chapter by Cheryl Aguilar on Introduction to Cluster Analysis is a very nice introduction on the general ideas of clustering analysis. Thank you.